Hi. My name is Paul at the moment. Paul C. Betts on GitHub and Twitter. Hi. How's the conference going? Is it going well? Is it the end of the day? Everyone's exhausted and want to go drink, and I am in the way of that. But I have a few things to tell you about, and hopefully they'll be interesting. If not, you can just throw the tomatoes. It's fine. I haven't been up here giving talks in a while, so I'm a little rusty. We'll see how it goes. Cool. So like Nia said, I worked on Slack Desktop, which was the first Electron app outside of Atom. Electron was originally not kind of this separate project. It was really just like this library to host Atom, the text editor. How many people have used like Atom, the text editor before? It's pretty good. It's not bad. But then they realized, it's like, well, this is a really great tool to build this desktop application, but we think it could be a really great tool to build all kinds of desktop applications. So Electron is a way to build desktop applications that run on Mac and Linux and Windows PCs using web technologies. So we don't have to use things like Cocoa or WPF or Windows Forms, these things from the 90s. We can use web technology and kind of reuse a lot of the pieces we've built, we've used to build our websites to build desktop applications. And that's really cool because it means that we can do interesting desktop-y things like, open users' files and documents and stuff like that, and show notifications and kind of do things that desktop apps can do. But we can do them in less than the bajillion years it'll take you to write WPF and Cocoa apps. So that's cool. So I spend a lot of time. I have this thing. Who knows who Raymond Chen is? Raymond Chen is this famous developer at Microsoft. He's a prolific developer. And he has this habit of answering every question that could possibly be given to him. He's on like a million mailing lists, and he just responds to them always. Because he wants to help people. He wants to he knows the answer to a question, and he can answer that question and help them out. And so this compulsion to answer all these questions is called Raymond Chen syndrome. And I have Raymond Chen syndrome, unfortunately. So I spend a lot of time in the Atom community Slack and these other places trying to answer questions and help people out, and Stack Overflow and stuff like that. And so I noticed some trends. When people are writing their first application in Electron, here's a few things I noticed people are doing. And they could be done a little better. We've got some suggestions on how to improve them. So here are a few things I noticed people doing in Electron apps that make users mad, right? So one thing that's really important with Electron apps is that memory usage matters. We'll put it in big words. Electron gets, in my opinion, a little unfair rep about using too much memory. People get a little grumpy about it. They're like, oh, my aim95.exe only used 1 MB of memory, and it did all this stuff. Why can't Electron apps in 2018 use that? It's mostly nonsense. But they see a number, and they get mad about it because of this. So this is every conversation I've ever had about Electron memory usage. Them. I'm so mad. I'm posting on Twitter. Mad people are on Twitter. That's where they live. So I'm like, okay, I understand that. That sounds really frustrating. So what's a commit charge? And so commit charge is this unit measure that's like the percentage of RAM that's being used by programs. That's not cache memory. It's not free. It's actually in use. And I'll have them look at the number. I'll have them look up that number, and they'll say, oh yeah, it's 45%. And this is the emotion that comes to me when I hear that. The RAM isn't doing anything. Why would we not use it? It's good to use. RAM that does nothing is not helping you to move faster. And so Chromium, in general, has taken the tack that we would rather have 60 frames per second all the time than have delays and jank and scrolling problems in order to save memory, which in 2018 is a pretty good choice in my opinion. We might as well use the memory in order to make a better experience. But on the other hand, so that complaint is kind of nonsense. But as Electron developers and Electron app developers, we can do something about this. Like, we should try our best to actually lower memory usage as much as we can, and not use it for no reason, because we want to respect our users and like respect their memory usage. And the problem is the people who actually get hit by memory usage problems will never be able to describe it to you. They're like somebody who's like a lawyer or like in finance, and they're like really good at lawyering and financing, and they don't care about computers, right? They pay us to care about computers, and so they're not going to be able to describe this problem to us when they're actually out of memory and their computer like grinds to a halt. They're just going to be like, my computer grinds to a halt, and this sucks, and it's a bad day. So we should do something about this. And the answer is load less stuff. It's so easy. So there's a few big things that consume a lot of memory. And so one of them that I'll talk about ones that are maybe not as obvious as you would think. So we'll talk about DOM elements. So DOM elements are any HTML tag, right? Any of the contents of the HTML tag. So like, for example, like the text in between paragraphs. That's a DOM node, but it is not a DOM element. That takes a lot, right? And a lot of times, those tags have associated information of them that takes a lot of memory. So, for example, and those aren't super obvious. So, for example, if you create a div that is 20,000 by 20,000 pixels, you set the width and height explicitly, right? And you put some text in the middle. That div, the actual contents is pretty small, right? It's just a div. But if you remember back to Jenna's talk, who went to Jenna's talk before us? It was really good, right? So she talked about the compositing and painting rule. And so like when it goes to take that huge div, it has to create a giant bitmap in memory, right? That bitmap, even though the div was maybe like 30 bytes of text, that composited layer is really huge. And so this really comes into effect. Of course, remember I worked at Slack, right? So like Slack consists of a message pane where you just scroll and scroll and scroll and scroll. And if you looked at the layers, they fixed this since then. Back in the day, if you looked at the layers, you'd see a giant, like 30,000 pixel layer. And that takes a lot of memory. They would also do this amazing trick that was like back in the like old days where they're like, we want to hide an element. But we're from the jQuery era. We don't trust hide and display none. What we're going to do is we're going to set it at pixel negative 20,000, 20,000. And what that immediately does is create a giant layer because it's got to put it at the top, off screen. And so things like that can contribute to memory usage. And so in general, we want to map the number of DOM elements, the number of DOM nodes and stuff like that, to the stuff we see on the screen, right? We don't want to have a bunch of DOM elements and nodes hanging around that is unrelated to stuff that the user isn't seeing, right? So like long scroll areas. Images are really big, right? Like, so if we have giant images, that's going to cause our memory usage to be really big. And we'll go over a few ways to deal with that. And the other one is much more straightforward, and things that developers think of is JS heap. Right? JS heap is all the objects you allocate in your JavaScript, all the libraries that you load, all the code that you import when you start your application. So that one's a little bit more straightforward. In general, you want to take a look at that nodes number and just make sure it's not crazy high, right? If you're getting around like the 40,000, 50,000, 100,000 range, then you might have something you can debug or like get rid of. This you can get to by going to the Performance tab in DevTools, checking memory, and then take a profile, just scroll around or do something. And then you'll see that nodes thing. Yeah, that's super useful, and it's really subtle. So I wanted to like point it out because a lot of people just, they're like, nodes, okay. So the easiest way in 2018 to solve this problem about too many HTML elements is use React or Vue and virtualizing lists. Who knows what like a virtualizing list is? Like React virtualized, etc. It means that, I'll just explain it. It means that, so you have a list of 10,000 messages, but on screen, you might only see like 20, right? Instead of constructing the associated DOM elements for 10,000 items, we're going to construct maybe like 40, right? And as the user scrolls around, we're going to stuff in the real values and put them on screen. So essentially, it kind of does that work of like only having the DOM elements on screen that you need. It does it for you. And so a common library for this is called React Virtualized. It's really useful anytime you have a really long list. You want to use React Virtualized because you don't want to have that all in the DOM. It uses a lot of memory. Cool. So here's an important part. So a lot of this advice has just been like applies to all websites. Like you could use it for like any web application. This is kind of specific for Electron. So Electron is interesting because it's kind of like a different environment than the web because you're loading everything locally. So it means some of the trade-offs are a little different, right? Like you're like, oh, like it's like I have a network that's like super, super fast and loads at 1 gigabyte a second. Which is kind of true, but it means that everything you're loading on startup in terms of JavaScript parse, which normally isn't as big a deal because network always is way bigger than parse time. Parse time is now a big deal. So for example, if you load RxJS, which is we used a lot in Slack desktop, if you load the full version, it can take like up to like 1.5 seconds of parse time, just the JavaScript evaluating that giant file and then figuring out what to do with it before your application loads. And so parse time and anything in the startup path is the amount of time between the user clicking your app and it opening. So that's a huge important thing. You want that to be really fast because desktop apps feel like desktop apps when you double click on them and they open, when they don't take forever. So even though we've got this amazingly fast network and we can load all this stuff really fast, parse time, the flip side is that we really care about initial paint. And so anything that gets in the way, the libraries you load on startup will definitely get in the way of that. So it's also bad for memory usage because node modules never get unloaded. So once you load them, they're stuck. There's some clever hacks you can do to kick it out of memory, but those are like taking over the node module system. In general, libraries, once you load them, they're loaded. So we can see this. The good news is that this is really easy to catch. All you've got to do is go into the performance pane and refresh while recording, and you'll spot it right here. You can see module.require, module load, sort of stepping through the node module system. And if you look in top down, you can see what modules are taking the most amount of time. And so that makes it kind of easy to say I'm loading all of Moment.js, and Moment.js includes all these crazy time zone table data that's really huge, and maybe you don't need that, right? So these kind of things are really easy to do. They don't take a lot of time, but a lot of Electron developers, I find, just kind of don't think of it. And so to make a great desktop app, we should think of these things. We should think of memory usage, and we should think of startup performance. And the good news is Chrome dev tools are really great. They're some of the best developer tools in the world for debugging and profiling and stuff like that. So that's cool. So we've got the tools. We should use them. Use the heap profiler. So if we go in the memory tab in Chrome DevTools, it'll tell us all kinds of stuff. It'll tell us, we'll be able to take snapshots of memory usage, and we can see a certain amount of memory. This is a snapshot of literally a blank Electron app. Electron Forge app. So like we can see that the vast majority of memory usage is compiled code, which makes sense because there's nothing else. And so, but we can see by type, like what's interesting in here, we can see delta snapshots. So we can take a snapshot and then maybe like use our app or load a feature or something like that, and then take another snapshot and see what changes. This is useful for tracking down like memory leaks and stuff like that. It will tell you, this is a little hard to understand or like kind of dig through like why something is still in memory. Like, so it has this thing called retainers, which are like the things that are keeping it in memory. Remember, like JavaScript is a garbage collected language. So like the reason that something is in memory is because something else is referencing it. So you have to dig through and see like, oh, this is being held onto by window, right? And window never gets unloaded. So like this can be a little bit of some magic, but I'm sure that there's lots of good talks on it. But in general, like this will tell you node memory that you're using, like loading node libraries. It will tell you about your application memory. It'll tell you about most things that are interesting. So we want to drive this number down. Cool. So performance is cool. Memory usage is cool. Another thing that I see a lot of new Electron developers, they're often coming from a web developer world. They're not used to native development. And so they get this idea, it's Chrome and Electron have this concept called the multi-process model, right? So your program in an Electron app starts off as a node script, right? Like there's no DOM, there's no HTML. It's just a node script that's running, but you have this magic class called a browser window. Right? And so when you create this class called browser window, just like a new browser window, you will create an entirely separate process that loads an HTML page. And that HTML page is going to have like DOM and CSS, and it'll run its own JavaScript and kind of do all the things that you'd expect. And it represents like a single window that's open. Right? And so the vast majority of Electron apps, just through like kind of coincidence or UI design, open a single window. So like Slack Desktop opens a single window, and most chat apps open a single window. That's not required, it just happens to be that way. So most simple Electron applications are going to have two processes, two node scripts running at the same time, or two like kind of JavaScript environments. It's going to have the main process and what's called a renderer process. And so the renderer process is the one that can create DOM elements and stuff like that, and the main process is the one like our startup one. And so people see that model, and they're like, oh, main render, front end, back end. And that's a really easy mistake to make because it seems like that's how it should be, but it's not. It's not at all. So we don't want to run stuff in the main process. But what about, no. So the main process is it's not the back end. It's not a background thread. People want to treat it as like the background process that I can run stuff in the background and do all this really intensive code work. It's not the server. So the main process is simply for orchestration. We don't want to do anything in that. We just want to have the main process tell other processes what to do. So the main process actually does a whole bunch of stuff inside Chromium. For example, the main process handles all the network requests, right? So like when you make a network request, it gets sent from the renderer to the main process. The main process actually does the network request, comes back with the data, and sends it back to the render process. The reason it does this is so that it means that in Chrome, the render process, essentially like the contents of a tab, never have access to directly make network requests. Or it's because of sandboxing. So we want that render process, the one that's actually executing remote content, to have as little privileges as possible. Of course, in Electron, we throw that all out the window. Render process can do whatever they want. It's neither here nor there. But this is the important part, is that running code in the main process means that every other process grinds to a halt, basically. Because Chrome is always sending these messages to make network requests, to do things like the main process owns the actual native window, right? So like you create a window, On Mac OS, it's like an NS window, and like Windows, it's a Win32 HWind. The main process owns that, and so like you do like a resize, right? And so it's got to like signal via IPC, via sending messages back and forth, to tell the render, hey, like your size used to be this number, now it's that number. You need to redraw. So Chromium has all kinds of these messages that it sends back and forth between these two processes, that you don't see, that you don't have to worry about. But the problem is that when your main thread is busy doing stuff that, like, I don't know, you calculate the digits of pi, or like you're running this thing, or like you're running a server, it can't do any of that stuff. And more importantly, if a render process is waiting for a response, it can't do anything either. So spinning on the main thread, main process, blocks all of the render processes who are like get stuck waiting. So it means that in general, the more your main thread, the main process does, the more your app is going to feel glitchy and janky. You're going to get like weird like delays and like scrolling, or like the app's just going to feel like glitchy, basically. So Electron actually exposes IPC between processes. So we can send messages between like the render and the main process. And so it exposes a synchronous way that actually like stops and like asks for a response. And so what's tricky is that if you use, one of the things that's really common in Electron is to use the remote module. How many people have ever used the remote module? It's really common in Electron. So the remote module is a way to access things on the main process from a render process. It's really convenient. But the problem is it's also really slow because it has to use this synchronous send. It has to wait for a response. It stops the render process, asks the main process a question, gets back a response. And so if you do that like once, it's not a big deal. If you do that by accident in like all the time, is like from like an on-click callback or an on-scroll callback, you're going to really grind. Even IPC send is asynchronous, but it's not enough. Because you can say like, if I send a message from the render process to the main process saying like, calculate digits of pi, the actual, I didn't block, but the main thread is still, or main process is still doing a ton of work. So that means that any other messages that Chromium is setting internally or you need to send from the render process don't get processed, right? Because it's too busy calculating something. The main process, really the only thing you want to do in there is tell other processes what to do. So it's kind of like this like kind of message bus, right? We're sending information between windows, right? So if we have two windows and they need to share like some kind of state, we'll send messages between them. Certain things you have to set up in the main process, which is kind of unfortunate, but it's how it works. And so like, for example, like menu items, because the main process owns the window, it also owns the menu associated with the window. So menus are in the main process. We have to tell the window render process about these events. And so a lot of like what you'll do in the main process is just kind of routing messages, like sending them back and forth. And so, or like if you want to bounce the dock, right? So like on Mac OS, you have these your programs are in the dock, and you can like bounce it to like tell them there's like a message or something. Or if you have like a menu bar or like a tray item on Windows. And there's a bunch of APIs that only work in the main process, like crash reporting. We want to do that in the main process, but in general, we don't want to do anything in the main process. So you might ask yourself, like, how can I do anything? Like, if I running code in the render process, causes my app to be slow because like I can't, the render process is the thing that draws my UI, and the main process causes the app to be slow because it causes all this jank. Like, where can I run anything? So I learned about this trick from the VS Code people. They have all kinds of stuff that they run in the background, right? Like every time you're typing in JavaScript, they're running like liners, and they're running like, TypeScript is compiling in the background. They're doing all this stuff. So how did they do it? And so what they do is this super clever trick. What if we create a browser window, but don't show it, so it's hidden? So now we've got a process that has a DOM, technically, has CSS, technically, but more importantly, has like a JavaScript run loop that we can do stuff in, but nobody can see it. It can grind all it wants. It can like spin all day long on 100% CPU, and it won't affect the performance of our application. So that was a super cool trick. And so what they do is they took it even a step further, and they said like, oh, well, what if we had a pool of like 4 background browser windows, and they just like sat there and like waited for requests, and like we could just put something in a queue and treat them like threads. So they essentially turned browser windows into like task pool threads, which is very clever. So I created this library called Electron Remote, which is impossible to Google because as soon as you type it, you'll get the Electron Remote module, the synchronous one. I could have came up with a better name. So the cool thing about Electron Remote is it's just as convenient as a remote. It gives you like this fake object that you can work with and just call methods on. Like you can just pretend that it's just like a regular class. But it's all asynchronous. It means that if you call a method, its return value will not be int or bool. It'll be promise of int or promise of bool. And so that conversion is automatic, and like it will read down the prototype of some object and then generate a fake one on the other side. So that's super cool. It uses this feature of ES 2015 called proxies. Once you figure out how proxies work, you'll try to use them for everything. And the V8 team will get really sad because they're really slow. And they'll be like, oh no, that breaks every fast path we can find. But for these, when we're going over remote processes, like we kind of don't care that the overhead is not a big deal. So one of the things that's super useful about Electron Remote is it lets us call into render processes from the main process. So we can take a window we're in the main process here. We take a window, and we get this like fake object called mywindow.js. It's confusing because we're talking about browser windows and also like the global JavaScript window object. So this is the global window object of some window. And so now we can just call methods on it. We can like call getters. We have this kind of magic syntax for like getting a property, because getting a property is also asynchronous, even though like actually getting a property is never asynchronous because it just returns value. We can call methods on it. So we can get navigator user agent even though in the main process that's not available. And we can do this asynchronously. And I lost a slide. So Electron Remote also implements that idea. It was supposed to be in a slide, but I think I messed up the slides. Anyway, Electron Remote also implements that idea of the task pool, right? So you can actually just say like, write a module that does a lot of stuff, right? Like it does some CPU intensive things. You can hand it to Electron Remote, just like here's this module. I want it to be in some other windows, and it'll hand you back this fake object that is the module. Right? So all the same functions are on this fake module object that would be if you just required it. And then as you call methods, it'll be sent to like, I think the cap is like 4 windows, and it'll spin them down as they're not in use. Right? So like as you start calling methods, it'll start creating more windows up to a limit. And then any other requests will be queued. So you can do these really like computationally intensive things in the background and not worry about making your app slow. The other thing that it's nice for that we used at Slack Desktop is that if you have code that's really crashy, maybe calling into a modern Windows 10 operating system function that always crashes for no reason, the thing that gets taken down is a random task pool thread. And you're just like, oh no, it's gone, sorry. So you can run all your crashy code in some other context and not worry about it breaking your app. So that's super cool. And it's really easy to use. That's the thing I like about it. It's I've described all these complicated things, but like the actual user interface to this library is just like really straightforward and easy. So that's cool. So that's one way to instantly improve performance in your Electron application. Is just never do things in the main process. Cool. So I want to talk about another web API. This is actually a browser API that is implemented in Chrome, but not other places, called request idle callback. And so this works in like regular Google Chrome, and it's really useful for making responsive web applications. And so one of the cool things about Electron in general is because you're guaranteed you're on Chrome, and you're guaranteed you're on some version of Chrome. So you can go to like who knows about like chromestatus.com? So chromestatus.com is a site that the Chromium team maintains, and it shows all the cool stuff that's coming in Chrome. Like basically it just shows this list of features, and you're like, hell yeah, that's cool, I'm using that. But normally, if you were writing a web application, you'd be like, oh, this looks cool, I'll use this sometime next year when there's like a polyfill and like people get around to implementing it on IE and like all these other things. But you're in Electron, so you get to use them now, and you don't even have to care about anyone else but Chrome, which is awesome. And so request idle callback is one of these really great APIs. So it's like set timeout in that you're running something on a timer, like you're running something later. You're deferring an operation. But it's guaranteed to run when the UI isn't busy. Now, trying to do this with any other API is really difficult. Like, so request and iteration frame will kind of do it, but not really. Set timeout is always going to run at a certain time, and you can never guess if the user is going to move a thing. Request idle callback is guaranteed to run only when the user isn't doing anything, which is great. And so it kind of goes a little further. It lets you, it gives you a function that you call that says like, gives you the amount of time you have before the user is going to do something. Now that's kind of reading the future, but like that's kind of the idea is like, we guarantee you have at least a chunk of 300 milliseconds to do something. And so you can keep asking that. You can do an operation, like say you're like running through, like you're saving 100 elements to IndexedDB, and that takes a while. And you might save them like 10 at a time. So you'll save 10 and then ask this callback, like, do I have enough time to save 10 more? Save, save, save. Oh, I'm out of time. Then you schedule it again. And so anytime you want to like write app data in the background is really cool for request idle callback. Or in general, like sending like telemetry data, like Google Analytics stuff, like anything you want to do in the background, and you want to guarantee that like it's some time when the user isn't doing stuff. Oh, and there's my Electron row slide. I found it. Yes, cool. Yeah, so this is the API, right? Like you give it the name of a module, and then you run it through require task pool, which is just like require, but it puts it on a task pool. And then you can call all your methods, like calculate digits of pi, and you await it, it returns a promise, yada, yada, yada. Cool. So some more performance advice. How's this going so far? People enjoying this? Good? Yeah? No tomatoes yet? What? All right, so more advice. Just make an HTML page. And so what we want to avoid is this. This is the worst loading screen. And it's because they're like trying to, a lot of people, it seems really tempting, and there's a lot of like pros and cons to it, but like trying to make your app Electron just like a frame of a website is really easy to do, but there's like from a user perspective, it's kind of a bummer, like because they see this, and this doesn't feel like a desktop app. This feels like a web app, like a web page in a desktop frame. And so there's a lot of like, if you're making a remote content app, like a hybrid application, there's a lot of things you can do. You can set up service workers, you can do all this stuff. But if you're starting from scratch, it's really great to just like think of writing an Electron application as just like, I'm going to make a static HTML page, right? I'm going to have a folder full of HTML and CSS and JavaScript. Now that isn't to say you have to use, you can't use like Babel or Sass or all these things, like all this modern web technology. You can totally do that. But the idea is that we want to have all of our content at the end of the day be local, right? So it's downloaded with the application. When the application updates, you get a new version. That's the easiest way to skip a lot of like security problems, a lot of performance problems, because anything local is going to load really fast. So like we know that it's going to load really fast. It's going to set you in the mindset of like, I'm a desktop application. I'm going to save like cache locally using like local storage or IndexedDB or like any other storage format. It won't get you in this mindset of like, oh, like the minute I load, I need to make a JSON request to like, load the actual data of my app. And so having this desktop mindset when you build the desktop application is really great, and like you'll end up with a better application. And offline mode is like way easier because you're already thinking from the beginning like, oh, like it needs to be on this computer. Just an HTML page is kind of easier to manage, right? When you create a hybrid application, you have to create like kind of like you're loading remote content into a local context and then running it, right? That's really dangerous from a security perspective. And you have to take this really careful thing to like decide like what APIs are available to the remote side, and then build this kind of like firewall to like only make sure that they can do certain things and not other things. And it's really easy to mess up. When you get rid of this security boundary and say like only code that's distributed with the app is going to run, that makes security way easier. So one of the things that's really important is that code, your policy of only local code that's running, cross-site scripting is so important. So if somebody can like send you, a messenger message or whatever that gets parsed as HTML and then executed, like you're like evaluating it, you're loading remote content and running it, right? And so it's really you have to be really careful with remote content to like parse it and run it instead of just like throwing it in an HTML page. Right? So if your like JSON API consists of like an HTML blob that you just like cut out and then throw into a DOM element, then you're going to have the same security problems as loading remote content. Cool. So another thing that people want to do is they want to run web servers in their desktop applications. So they're coming from a web world, and they're coming from a web tooling world, and they're like, oh, like I got to set up like Express and like point Electron to localhost in order to make my app work. You shouldn't do that. You really shouldn't do that in production. Because like, what happens if more than one person uses your app, right? So like in the enterprise, it's really common to set up like a terminal server, right? Like this big, huge box that has 50 users. And people install your app, and then all 50 users can use it. Well, if you all expect that localhost :1234 is where I'm going to put my web server and then connect to it from Electron, now you've got more than one person doing it at the same time. This becomes a huge security problem because now your web service that's running on some person's laptop is a great way to like move between users, right? And one of those users could be like a website that requests from localhost. If your app runs as admin, which it shouldn't, but it can, it's a great way to local escalation of privilege, or have websites be able to run desktop code if they're really bad. And the good news, and the people do this not because like they're lazy or whatever, or because they want to run a lot of their web tooling, right? So they want to use like React, and they want to use React hot reload and stuff like this. So the good news is that there's a way to do that without having to run any kind of local service at all, local web server at all. So there's this library that myself and some other people, mostly other people, have worked on called Electron Forge. So Electron Forge takes all of the annoying parts of writing an Electron application, all the stuff that isn't writing your app, like setting up builds and setting up Babel, and it's a little bit like Parcel for Electron applications. In that, it's trying to get rid of all the like grunt work that you don't want to do, and save you to be able to just write your application. And so it sets up all this stuff like React and Vue and TypeScript and all this stuff out of the box. It's really easy to use. It's a little bit like Create React App in that it does all this stuff for you. So we don't need Express. We don't need Webpack. It's going to do all this stuff for you. Don't During development, it'll set up like hot module reload. So like as you're saving, it'll like reload the application, like reload components. It does all of the, we took all of the knowledge that desktop developers have around like packaging and like creating installers and code signing and stuff like that, and did all that for you too. So it's a really great way if you're writing a new Electron application to just like spend time on the fun stuff and not spend time on build stuff, which is like the opposite of fun. But I like Webpack. Who likes Webpack? It's a very powerful tool that sometimes is not a joy to use. I like Webpack too. I think that like it's like, you can't argue with success, right? Like it powers some really huge websites and it's a great tool. Unfortunately, using it with Electron gets a little weird. Because Electron or Webpack, when you bundle all these things, right? You're writing in your code require statements or import statements, right? And Webpack is taking all those import statements and kind of mushing them together and creating this one giant file called myapp.js. And so it has this concept of require. And so it implements require because it implements modules. Electron also has modules, but it uses the regular node module system. So now when you type require, you're getting Webpack, but sometimes you need node. So like the biggest problem that you hit when trying to do Webpack is that as soon as you go to load a native node module like spell checker or like things that do notifications, you blow up. And so packaging becomes like this like really weird dance of like trying to like exclude stuff and like tell like to ignore Electron, ignore this module. I've got to figure out a way to have like a node modules folder and Webpack's not node modules folder. So now I have to have two node modules folder, like one that's in the app and one that's not in the app that gets Webpacked. Because if you try to Webpack a native library, then of course it's going to fail. And so it gets weird. It gets really frustrating. And so like Electron Forge kind of handles a lot of stuff for you. So sometimes you need Webpack. Like people will do these very kind of specialized things, and they got to use Webpack, and it's a kind of a bummer. But if you can, Electron Forge is great. Cool. So mostly in this talk, I've talked about performance, memory usage, very like do your homework kind of topics. Blah, performance, security, memory, thanks, Mom. So now I'll tell you about a thing that has nothing to do with performance or memory or do your homework kind of topics. And I'll talk about something in this library that's really, in my opinion, under-marketed and like not as well known as it should be. So it's called NodeRT. And so NodeRT only works on Windows. And what it does is it lets you call basically all of the really cool Windows APIs from JavaScript in Electron. So this is really powerful. So we can call Windows 10 APIs from Electron super easily. And so I say Windows 10 because it's calling because the name, as the name NodeRT suggests, it's calling into the Windows 10 like new style applications, like the UWP applications. And so if you're trying to build a desktop application using Electron, you want to be able to do these desktop-y things. And so there's all kinds of really interesting things. So like digging through, like you can get the geometry of the display and like kind of all the features of like how many monitors they have, so you can like save off that information, like save off where the window is in the thing. You can call geolocation, which in Electron doesn't work because you need a Google token. You can do things like, I didn't even know this until like I was researching for this talk. Windows apparently like has an OCR engine built in. You can hand it an image and it'll be like, here's the text. I didn't even know it could do that. That's super cool. You can do things like capture the screen, like all the things that like desktop apps can do. You can like query the power information, like say whether you're on battery or on plugged in. You can say like, oh, I'm plugged in. I'll like be a little bit more aggro about like doing stuff. What about Mac OS? There's no super easy way to call macOS APIs from Electron. You have to write a native Node module, which means that you're dumped into writing C++ code, which is a bummer. Mostly, there's a lot of like simple, for Electron, there's a lot of really simple Node modules that you can kind of like, cargo cult, like copy the whole thing and like kind of replace the inside. So that makes it a little bit easier. You can do really simple things also with this module called Node FFI, which is a very old, like from the beginning of Node.js, that lets you call C functions from Node. It's really easy to mess up because you're actually writing like a C like header definition of like a function. And if you make a typo or like say that something is 8 bytes when it's 4, Node FFI will totally trust it and then corrupt the stack and bring down the render. But it can be useful. And Node FFI is actually cross-platform. Like you can use it on all 3 operating systems, which is cool. But Node RT, really easy to use. The API is really straightforward. So how can I figure out what I can do? If you install Visual Studio, there's this feature you can get to if you dig. How many people have done native Windows development or like Windowsy things? If you go through the joy of installing Visual Studio 2017, you can open a blank app and then get to this thing that lets you see all the APIs. And so you can kind of browse and get some ideas, like what can I do, like poke around. And so here's how to do it. Like you create a new app, a Windows Universal app. Doesn't matter, blank, whatever. You go to the right-hand side and go add references and go Windows desktop extensions, because UWP runs on all these different platforms like the phone that doesn't exist or like a HoloLens or an Xbox. So you got to tell it, like, I want to run on a desktop computer because it'll add extra stuff. And so then you go to this menu item called View Object Browser. And so then you can like poke around in all the libraries. It's like kind of like this automated documentation generating thing. Like it's actually like reading the definition through the class file and saying like, oh, this has these namespaces and these classes. You have to find this extremely obscure name, windows.foundation.universal API contract. This is new. I didn't know about this until I tried to find this and couldn't find what I was looking for. And then you can scroll through. You can like look at the like, oh, I can do application model. Like I can poke around like chat context, like stuff like that. There are a few things that you can't do unless you're a Windows Store application. So like server push notifications are one thing you can't do. So being able to woke up the app. Oh, I'm out of time. So in summary, make an HTML page, load less stuff, and load it in the render process. Do cool stuff on Windows 10. Thanks. Cool. So questions? Rants, raves?
We actually have 5 minutes, so if you wanted to do one more slide, we can. Otherwise, we can just start with questions.
Oh, no, it's OK.
OK, cool. Yeah, question?
Hey, thanks. How you do automation tests for Electron app?
Yeah, so for Electron apps, you can do you can connect Electron to Selenium, just like you can with a browser. You need to do a few kind of like backflips to make that happen. Like basically, when your app starts up, you'll see in the command line, in the parameters, that somebody's trying to start Selenium. And so like, then you can kind of activate like a special mode of your app, which will just like load the app and like point it at Selenium. But in general, like a lot of the web techniques you would use on the browser will do.
Oh, hi. Suppose you want to send push notifications from the server to the Electron desktop app. How's it done?
Yeah. So in general, like on desktop, like push notifications are not super valuable. Like the idea of push notifications are waking up the app when it's not being in use, right? But so that's, you can be a Windows Store app and you can get that, just like on macOS when you have to be in the App Store to get push notifications. But you can still, push notifications are separate from showing a notification, right? So if your app is open, you can use WebSockets, you can use like polling or like any other kind of like standard thing to know that there is a notification and then just show one yourself. So on Windows 10, even if you're not a Windows Store app, you can still show notifications, like native notifications, and show like all the kind of like buttons, and you can do all kinds of really interesting stuff with Windows 10 notifications. You just can't be woken up unless you're a Windows Store app.
So maybe I just use WebSocket or poll. I mean, polling is probably a bad idea.
Yeah, you wouldn't want to poll, but you could use a WebSocket. Yeah, so in like any way that you on the web would like listen for messages.
Cool.
How does the same origin policy work with an Electron application?
So because your app is running in so you can disable it, but you shouldn't. In general, because your app hopefully is running under a file URL, file URLs don't have same origin policy. So just like if you load double click on a web page or like an HTML file on Chrome, so you don't have to worry about like being in the same origin policy. So one thing that will trip people up is that because you're a file URL, you don't have cookies. So like if you try to use like Google Analytics, it's going to try to save a cookie to make it work. You don't have cookies in a file, but there are libraries to like fake it out, like create a fake document cookie store that like saves local storage instead. So yeah. But there's also you can actually like nerf all web security, which you should not do, but you can do it.
All right, do we have any more questions? Yeah.
So you mentioned some strategies to offload things from the main thread. Are web workers just not a possibility?
Web workers are a possibility, but they have a lot of caveats in Electron apps. So web workers, what you'd probably want to do is kind of like require a bunch of native code or require a node module. Originally, web workers couldn't do anything related to node modules. And now they have they can do certain things, but not other things. There's like a guide in the Electron docs that says like exactly the kind of caveats and limitations. So those work too. Like if you can jam what you want to do into a web worker, that's great. In general, like the reason people don't use web workers that much is because all the data you send back and forth has to be over messages. And so if that data, like usually the thing, you're offloading it because the thing is huge, and you can't send it as a message back and forth because you're sending like this giant IPC message and it grinds. So it limits the utility of web workers. But yeah, if you can fit it in a web worker, that's great because like the debugger experience is a little better, and like you can actually see that in Chrome DevTools.
I think we have time for one last question. Does anyone want to ask one? All right.
Say I happen to be a front-end engineer writing code that may or may not get used in an Electron application. Are there any things that I should be aware of?
I think as a front-end engineer, one of the things you can do is just think about like, if you pretend that you were a desktop app, like you're in a desktop app, what would you want to do? And like, if you want to do something, the desktop team can probably do it. So like, if that API doesn't exist and you're like, oh, like, because a lot of like front-end engineers, when you work in this hybrid environment, they get used to the restrictions of the web, and they're like, oh yeah, I can't do that because like, I can't do that. In Electron, you can totally do that. And so like, if an API isn't there, like, just kind of come up with like a contract on like what it should look like or what you want it to look like, and you can probably do it.
All right, thank you so much, Paul. Let's give another round of applause.
Cool. Thank you so much for your time.